For this experiment, we're going to look at the effect of calcium on cardiac muscle contraction by first of all putting the muscle in a calcium-free solution, and then we'll examine the effect of putting the cardiac muscle into a solution with 2 times the amount of calcium. First of all, let's look at the calcium-free solution. The procedure is given in our notes as shown here, and now let's have a look at how you carry out this experiment. First of all, we'll change over to a new piece of tissue, and then we'll start the 1 in 30 second macro in order to equilibrate the tissue. And then we'll continue to stimulate until the recordings are stable for several readings. Now here we see Craig filling one of the 2 5ml syringes with calcium-free Ringer's solution, ready to do the first wash. The other syringe he's holding is empty, and he'll use that to empty the previous Ringer's solution from the tissue bath. Right, so then once the readings are stable, we'll then quickly suck out the previous Ringer's solution using the empty syringe, and then refill the bath using the calcium-free solution. All right, now this is really interesting. Have a look at this response here. Now we added only 1 change of calcium-free solution 5 seconds before that reading was made. So look at how quickly that response occurred. So we'll just speed up the footage for the sake of time, but by this stage we've done 4 changes of calcium-free Ringer's solution. Then we had done a 5th rinse prior to the recording shown on page 8, and we did another rinse prior to the recording shown on page 10. And finally another one prior to the reading on page 13. So now here we are about to take the last reading. We found that reading 26, 27 and 28 were about the same level, so we figure we'll just take one more at 29, and that ended up a little bit wonky, but that doesn't matter. And then we changed the solution back into normal Ringer's solution, ready for the reading on page 30. So we've done 1 change into normal Ringer's solution by page 30, then by page 31 we had done 3 more changes, and so we've done 4 changes altogether in normal Ringer's. Right, now one thing to note that these types of controls where you return your experimental tissue back into the control bath solution are called washout experiments. Now they're a really important way of demonstrating that your treatment, your experimental treatment, for us that was calcium-free solution, was the thing that was causing the effect that you observed, especially when you're seeing a decrease in the effect of whatever it is that you're looking at, so a decrease in contraction in our case. When you're seeing a decrease like that, it may just be that the tissue is becoming dysfunctional. Maybe it's becoming old, maybe it's dying, maybe there's a lack of oxygen. There's many reasons why a tissue could be losing functionality. And so you want to demonstrate that the reason that the contraction was decreased was because of a lack of calcium in the external bath solution. And so a good way of doing that is to return your tissue to its normal Ringer's solution, and if the tissue is functional, then the function should come back. If the reason for the decrease in contractility, on the other hand, is because, say, something else was going wrong, then presumably when you put it back into normal Ringer's, then you won't get a return in response. And so these washout experiments are a really good way of demonstrating that the effect that you're seeing is due to your experimental treatment. Alright, now here we are at the end. We've done a total of 5 washouts with normal Ringer's at various stages, and the responses had largely stabilized, so we decided to stop here. Alright, so now this is what this same data file looks like opened up in LabChart Reader. I've renamed all the pages according to when we did the various changes of solution, so you can see when all of them were done. So for example, prior to page 30, we had done a single change into normal Ringer's, and so that's how I noted that here. Prior to page 31, we had done 3 more changes to rinse out the old solution, and so on. So hopefully my labeling scheme makes sense. So now let's switch over to see what happens when we change our solution into a 2 times calcium solution. So first of all, we'll start up our macro again. Now, this is just a couple of seconds after we've finished the previous reading, and this is the same tissue. So all we're going to do is change out this tissue into a new 2 times calcium solution. So we'll just do a couple of readings just to make sure, and we can see that with 2 readings, basically we're getting the same response, which is great. So our muscle is nice and stable. So here we'll do our first change into 2 times calcium solution, and we're doing it 15 seconds before the reading for page 3 for anyone who's interested. And here's our first reading in 2 times calcium solution, and you can see how big the change is and how quickly that occurred. Here we do another change into 2 times calcium solution before page 4, and so on. And again, I'll label the data file so you can see when we did the different washes. And then here we are at the end, and the amplitude of the contraction has become stabilized. So again, we'll stop the recording here. Here is the data file opened up in LabChart Reader, and you can see the labels that I've added to each of the pages. So you can see when we change the solutions. And so you should then open this file up and perform the analyses for this activity as described in your notes here.